So the title of my talk is Understanding OpenStack Deployments, and particularly understanding OpenStack deployments with Puppet. And this is a huge topic. OpenStack is a large ecosystem, and Puppet with OpenStack is also a large ecosystem. And so in the 40 or so minutes that we have, we certainly can't hope to cover everything about it, but what I do want to do and hope to walk away from is to give everyone a good understanding of the tools that are out there, a sense of how to use them, but also how to engage the really strong and vibrant community that we have in OpenStack and that we have in the Puppet OpenStack community, so that if you're interested in doing your own OpenStack deployments, you have the resources available to get started and know where to turn. So who is this guy? As I said, my name is Chris Hoge, and I got my start with OpenStack back at the University of Oregon. I was, if you know about OpenStack, they have a new release every 6 months, and it's sequential, alphabetically named. And so Austin, Bexar, Diablo, Essex, Folsom, and so on. Right now they're up to the Icehouse release. We're coming up on the Juno release. And I started with OpenStack back in the Diablo, and I deployed Essex at the University of Oregon. After 3 years of doing that there, working on a large cluster, I went to Puppet Labs, where I was the OpenStack engineer, and I helped manage the Puppet OpenStack community, which was a fantastic group of people. And then an opportunity came up for me to join the OpenStack Foundation, which is where I've been for, this is my second week now, and so it's pretty exciting. And that's my dog, Shotzi, and that's us living in beautiful Oregon. So what is OpenStack? OpenStack is a global collaboration of developers and cloud computing technologists attempting to produce the ubiquitous open source cloud computing platform for public and private clouds. What this means is that OpenStack wants OpenStack to be everywhere, so that whenever you need a cloud, you can go to an OpenStack cloud and you know it's going to work with all of the other OpenStack clouds. It was founded by Rackspace and NASA, but it's now governed by the OpenStack Foundation, which is a not-for-profit governing body, which represents vendors, it represents developers, and it represents users. So, just to start off quickly, how many people here are familiar with OpenStack or have used OpenStack before? Is there? So it looks like it's a pretty good amount of people in the audience. How many people have used Puppet with OpenStack? So it's a little bit smaller, and we'll try to, and I'm assuming that everybody here knows Puppet. I was going to ask who knows Puppet in the room, but it seemed like it was an obvious question. Okay, but a little bit more about what is OpenStack? It actually consists of a number of different projects, open source projects, to achieve this goal of cloud computing. But it has but some of the projects in some sense are more of the foundational or more core projects. There's debate over which are the most core right now, but as a rundown, one of the fundamental projects is Keystone. This manages identity, this manages discovery of services, and this manages authentication. Whenever you want to make a request against OpenStack, you have to provide some sort of authentication, and then Keystone hands out tokens to all of the services to say that yes, this person is authorized. Whomever is making the request is authorized to use that service. And so it's really it's foundational. It's actually you could call it the keystone of the entire system. Next on top of that there is a network called Neutron. This provides network as a service. It allows you it sits on top of almost any network system you could imagine to give you absolutely varied software-defined networking. Neutron is a replacement for something called Nova Network, which is networking within the compute project, which is the next project here. Some people still like to use Nova Network because it's a little bit, even though it's not as flexible, it's a little bit more robust and a little bit more performant. But I think we're going to see in the next 6 to 12 months that Neutron's really going to take off and become one of the preferred networking services. So it's important. I like working with it, and I think it's important to talk about. Compute provides virtual machines computing, much like you might see on something like Amazon's EC2 or what you might get from the Rackspace or any number of other cloud providers. It can sit on almost any hypervisor that you'd want, and so you can use KVM, you can use Zen, you can use VMware, you can use Windows hypervisor. There's also block storage, right? All of the storage that comes built into compute is ephemeral. You get a machine, and when the machine goes down, all of that storage disappears. And so Cinder is a way for you to attach virtual storage to your virtual machines and provide some persistence to your data. There's also an image service, and so this is where you store your images. You can also index images elsewhere, and this is where you're going to boot your virtual machines from. And finally, there's a dashboard that kind of pulls it all together and gives you an interface to be able to work with all of these services in a unified place. There are also a bunch of other projects. There's OpenStack Swift, which is similar to S3. It's large object storage on the web. There's telemetry, Ciliometer, which gives you metrics and helps you integrate into billing. Orchestration for building out machines and scaling out automatically. A database service, which lets you spin up databases automatically on top of Nova instances. There's Sahara, which is MapReduce, which is built off of Hadoop. And there are many more projects, and it keeps growing. More projects are incubated and brought into to be permanent OpenStack projects all the time. But we're going to focus on these right now, because again, I feel my sense is that these are the most core projects that are required for you to build a functioning cloud. If you're interested in building a cloud, everything else is more of an add-on. It's more of an addition to it. Okay, so I've said a lot about OpenStack right now, but what does Puppet have to do with this? Well, right now, Puppet is the #1 deployment solution for all of OpenStack clusters throughout the world. It was one of the earliest solutions out there, and it's also one of the most popular. It's being used by, notably by places like CERN, which right now is running a multi-tens of thousands of node OpenStack cluster, and they're managing the entire thing with Puppet. And they're using the community-developed Puppet-OpenStack modules. And so OpenStack has this open development model where every project anybody can contribute and they can review the source code for any project. And then you have a core set of developers who are assigned to those projects who are, they essentially vote each other in through some sort of community process. And all of the Puppet OpenStack modules live within this ecosystem of OpenStack development. They're the primary OpenStack projects, which live in the GitHub OpenStack namespace, and then there are the community developed projects, which live in the GitHub StackForge space. Puppet's also used a lot behind the scenes. Right now, all OpenStack development depends heavily upon Puppet because so much of the infrastructure which is driving the continuous integration and testing of OpenStack in the background is being driven by Puppet. And so it's an incredibly important tool that tons of people are using, and it's important to know how Puppet fits into this environment. So I'm going to move on and give you kind of talk about OpenStack architecture a little bit more and start with a cartoon view of how OpenStack is built. Now, a lot of times this is the popular spot where a slide that's called the spider diagram is thrown up, and it shows dozens of boxes representing all the different services and how they communicate with one another. I'm not going to do that to you. It's going to be more simplified. And so, there might be some inaccuracies in this simplification, but it should give you an idea of what the basic underlying, what a simple OpenStack cluster would look like. And we start with the database and the message queue. These are the tools that are going to be used to communicate across your OpenStack your OpenStack cluster. The database is going to be storing persistent information that all of the services will be reading and updating as necessary. And then the message queue is going to give is the more imperative communication mechanism. It's where APIs and schedulers are going to tell services, start up a virtual machine, set up a network, create storage. And so the database and the message queue work together to transport all of the nearly all the communication across your OpenStack cluster. Now, sitting towards the customer and towards the user are going to be a number of different APIs and user interfaces. And so the one that you're most likely to interact with when you're first approaching OpenStack is Horizon. Horizon is a web interface that gives you a really nice dashboard to communicate with all of your OpenStack services that are being served by different APIs. And so Keystone itself is basically just an API for all of identity. But then there's a Neutron API, a Nova API, a Glance API, and a Cinder API. Sitting behind these are schedulers, oftentimes. Schedulers and other types of services. And so there's going to be a Nova scheduler that's going to decide where you can launch your virtual machine, or if you even have the resources to launch a virtual machine. You have a Glance registry, which is going to keep track of where all of your images are, whether they're off in the cloud somewhere else, whether they're being stored locally in, in some sort of large object storage or disk storage. Or a Cinder scheduler, which is going to try to find a location for you to put attached block storage. And in this view, these generally reside on a control node or some set of control nodes. Now again, this is kind of a simplified diagram, and if you grow out an OpenStack cluster, chances are you're going to separate your database server out and have that live somewhere. Keystone is going to be a very high traffic server, and so that may be sitting on its own somewhere. And this is also neglecting a lot of things like high availability, right? That on a production deployment, you're actually going to have things like CoroSync and Pacemaker, which are going to be load balancing and giving you high availability for your services. We're going to set all of that aside for now, but just be aware that, so I want you to be aware that this is a little bit of a simplified diagram, but it can get much more complex very fast. Then you're going to have a number of different nodes which also accomplish other tasks. And so in this model, we're going to have a network node, which is going to have all sorts of Neutron agents. That's going to handle your L3 routing, it's going to handle your DHCP, it's going to handle routing metadata requests. It's essentially going to be the heart of your network. You're also going to have some number of compute nodes, which are going to have Nova Compute services running on there, which are what's going to be managing your actual running virtual instances. This is sitting on top of libvirt. And you're also going to have a network agent, which is going to be connecting to your network to take advantage of your software-defined networks. And finally, you're going to have some number of storage nodes. And again, this is a bit of a simplified version. A lot of times it's very popular to actually co-locate storage with network nodes, for example. And so with storage with the control nodes. And so the control node itself might have a Cinder storage service running on that. All of this is somehow connected within the fabric of your data center. And so at the top, you're going to have some router which is going to give you your public-facing network. And you're going to have an API network coming off of that, which is where all of your API calls are going to go to, as well as an external network which is going to connect with your router. Behind the scenes, you're going to have one or two private networks. One for an administrative network, which is where your database and message queue communications are going to be going across, as well as internal API calls. And also a data network, which is where all of your software-defined networking is going to communicate between the Neutron agents on your router, on your Neutron router, and the compute instances. One thing to note is that you can actually, in this diagram, I like to think about these networks as being separate, but a lot of times those are actually, these networks are combined. There's nothing that says that they have to be separate networks, but when you're doing deployments, when you're building out your model, it's nice to think of them as separate networks because it helps you separate out the importance of them and what traffic is supposed to be going across. And the same for the administrative and the data network. There's no reason that your data network can't live on the administrative network. All of the data, if you're using something like Open vSwitch, all of your traffic is going to be flowing through some sort of tunnel, some sort of virtualized tunnel. Now, one thing to notice about this diagram and the previous one is that it fits in really nicely with the Puppet pattern that we would call roles and profiles. How many people here are familiar with the concept of roles and profiles? Okay, so it's a fairly good number. But I'll cover it again anyway, just for the people who haven't heard of it. Roles and profiles are a Puppet programming pattern where you have profiles which describe some sort of unique functionality that you want to know to have, and that should, by and large, be independent of other profiles. And so each of these, the APIs, the schedulers, the database, the message queue, the agents, all of these things could be captured in a profile. And then you combine these profiles to build out roles. And a role describes a node. It basically says what you want a system to look like. And so you could have a control role, you could have a network role, a compute role, and a storage role. Right? This is the model that I've developed my OpenStack module from, and in some ways it works very nicely. So now I'm going to give you the grand tour of the Puppet OpenStack modules and how deployments work. So there's a one-to-one correspondence between the Puppet modules and the OpenStack projects. And so there's a Puppet Keystone module to match to Keystone. There's a Puppet Nova module to match to Nova. All of these are hosted in StackForge. And they're community developed. And so if you want to download the modules, if you want to try them out, if you want to make additions or changes, all of the code is right there, and there's a huge community of developers who are there to help you do that and to review your code and offer suggestions. Generally, we're going to build off of packaging that's happening through Canonical and Red Hat. And so you're going to pick an operating system that you want to deploy OpenStack on, and that's generally Ubuntu, Debian, or some Red Hat variant. And then you're generally going to pull from the packaging that these companies produce. And so in this case, I think OpenStack is now part of the Ubuntu core distribution, although I think they called it the Ubuntu Cloud Server previously. And with Red Hat, that's going to be through their RDO. And you can run this on CentOS or Scientific Linux. It also tracks the major 6-month OpenStack releases. And so soon after the OpenStack release, the next one's coming up in the next few weeks. Some number of weeks after that, there's going to be a new Puppet OpenStack module release. And so the community tries to track very closely the releases that are happening and to keep feature parity. Plus, the modules are also available on PuppetForge. And so once they've been released, they're packaged up, they're sent to the Forge, the dependencies are handled there, and so it's actually possible for you to use the Puppet module tool to say Puppet module install, the OpenStack modules, and they'll pull that in with all the dependencies. However, the modules by themselves aren't entirely useful for deploying OpenStack. You wouldn't just go download the modules and say, hey, I'm going to start installing OpenStack with this. Generally, we have what are called OpenStack composition modules. And there are also a number of these that are out there freely available, some being developed under StackForge, for you to download and be able to test OpenStack or run your own deployments from. A few notable composition modules are PackStack. This was one of the first ones. This was produced by Red Hat, and it appeared in their RDO. It's available on StackForge. It's based on the Puppet modules. It's been replaced by StayPuft, which is kind of the next generation Red Hat installer for OpenStack that ships with RDO. There's also a Mirantis developed installer called Fuel Library. Right now, this is a fork of the Puppet OpenStack modules, but they've been working pretty hard in bringing this fork back in line with the main OpenStack modules, and they've given a lot of development effort. There's also the StackForge Puppet OpenStack Builder. This was started at Cisco, I believe, as a collaboration between some of the community members and Cisco, and it's also being used by some consulting companies out there. This is a great module that's going to give you a full-featured deployment, as well as the Inovance-based Puppet OpenStack Cloud modules. Right? Again, both of these modules are based off of the Stack Forge modules. And finally, there's the Puppet Labs OpenStack module, which is a very simplified OpenStack deployment based on that diagram that I showed you before, which is more meant to serve as a tool for testing. So for as code development is happening with the Puppet OpenStack modules, it helps with testing. It's also kind of a gentle way to get started and spin up some multi-node VMs and kind of see how it works. So all of these are great options if you want to explore, doing your own deployment, especially some of these down here that are more focused on production deployments. So we're just going to jump right in and talk about code now, because this is going to give you a sense of how the modules work. I'm not going to go completely deep into this and try to explain every line of code as we go along, but I do want to give you a flavor of what the modules look like and how they work, and how I've used them in my composition module. There are different ways to do it, but this is just supposed to give you a sense of how this works. And so using the rows and profiles, what I do is I start with what I call a base profile. And this is going to do a few things to make sure that I have all of the information, that the module has all the information it needs about the system it's being deployed upon to really build something out. And so I do that by including the OpenStack initialization module. Basically, this pulls in all the parameters that are going to describe what my system looks like. And so this is going to be the networks the four networks that I'm running on. It's going to be the passwords. It's going to be the users you want installed on the system. It's going to be setting up neutron networks. You also need to pull in a repository, and so there are a number of different ways to do this. But generally, you're going to go to, it's abstracting away whether you're using yum or whether you're using apt to go as your source for the OpenStack modules. It's also going to do some work to set up your database connections and set up some basic strings there, as well as just setting up a lot of IP addresses that are going to be specific for the machine that you're running on. And so, there's a function that says what's the IP for the management network, so that you can know the management address. One of the ideas is they're trying to abstract away the IP address from the device that it's on. And then just some helper things that, to make sure that things are consistent between what you've declared to be controller nodes and actually, placing profiles onto controller nodes. And so there's some consistency checking that goes on. So coming back to this diagram, the first things I'm going to show you about setting up are the database and the message queues, because these are some of the foundational pieces, right? How much time do we have? I'm going to kind of blow through these pretty quickly so that I have time for questions. And so what's happening here is the Puppet OpenStack modules have a way to automate the installation of RabbitMQ and make sure all the dependencies are satisfied. This is one of the reasons why the modules are really nice. There are so many dependencies and so many things have to happen in the proper order. By installing RabbitMQ through Nova in this instance, it's giving you a way to make sure that all of the services that are required are available, and that when Rabbit's ready to go, or if its server status changes, it can notify all the other services. Setting up MySQL, on the other hand, right now for this module, I'm making a direct call to the profile is making a direct call to the Puppet MySQL module. Actually, this is something that's going to be changing in a little bit because there are also two new libraries in the Puppet OpenStack ecosystem. One is called Puppet OpenStack Lib, and the other is called Puppet OpenStack Extra. Lib gives you basic functionality that is required for all installations, and Extra gives you things like gives you things like firewalls and high availability, things that are nice to have on top of your installation. And so the database server setup has been abstracted away into those libraries. But this is basically just using the modules that Puppet Labs publishes. I've also created this thing called resources because every single service is going to have to create a database. And so this is taking advantage of the defined resources that the Puppet language offers you. By abstracting away, by just giving it a title, you can do a complete database creation for all of your different services. Next, I'm going to move on and just talk about the Keystone and the Nova API. I'm going to skip over a lot of these other APIs because it would just be repeated information. But in Keystone, what I'm doing is I'm taking advantage of these resources. So for example, I showed you the database resource. But there's also a resource that tells you that, yes, I'm a controller, and it does some consistency checks and will throw an error if it turns out that you're trying to set up a controller on a node you haven't identified as a controller. It's also going to set up firewall, and so I've abstracted away the firewall, building out the firewall so that it's easy to just give it a name and a port to open up on, and it's going to open that port up on the proper network, and also make sure that the rest of the ports are shut down. A lot of these profiles have something, use a pattern that I've been working with that has common configurations. I'll get into this a little bit more when I talk about the Nova API setup. But common is just a way to just make sure I bring in a lot of shared state that is going to be, which is going to be on API nodes, it's going to be on server nodes, it's on the worker nodes. I set up my Keystone endpoint. And then I can do a number of things. The Puppet-OpenStack modules also provide you with some really nice resources for managing types and providers to manage resources within OpenStack. And so in this instance, I can actually create OpenStack tenants and users with the OpenStack modules, as well as things like networks. I can create virtual machine. I can create, I can make machine images available through Glance. It's a really powerful tool set that extends the Puppet OpenStack modules beyond just your basic just your basic setup, but also for your ongoing maintenance of the installation and the actual system itself. And here you can see, this is where I'm setting up users. And so, so this is a resource that's being applied there. And then we get to the common. The common where we're setting up the Keystone init class, and so you can see that previously I was the Keystone class was setting up the server, but this is setting up common configuration options. Now, why might you want the Keystone class there? Well, if you have other services that are depending upon Keystone authentication, say Tempest and testing, you actually want this Keystone information to be there so that it can read that data and be able to connect to those services. And so it's kind of nice to have these things around and be able to separate that out. You also set up an administrative password. Nova follows a similar pattern. There's a lot more firewalls to set up. We're still identifying it as a controller node. We're still identifying it as a database. We're also setting up basic Nova authentication. So you're going to set up all of your authentication tokens so that Nova can communicate with Keystone and say, I'm entitled to act on the behalf of a user, right? This gives Nova a little bit of superpowers within the system to make sure it can run. It includes its common code, which is a much bigger file right here. A lot of things that are going on. It's trying to determine if it's a controller or if it's a compute node. It's going to be setting up addresses. It's also setting up the Nova common code. Again, we have this common code here because we're going to be setting up the API with this, but all of the compute nodes also need this exact same configuration. So by putting it into this common code, we're reducing code duplication. Then setting up a bunch of Nova services like the API, the VNC, a number of different schedulers, insert, these are all different services that Nova is running to give you a complete and fully functional experience. As well as setting up the compute node, you can see that if it's not a compute node, it's going to make sure that this is disabled. But it's still important to have these compute options in your API configuration, as well as making sure that Nova is connecting to Neutron and making sure I'm setting up the Neutron networks. So now I'm going to talk about setting up a compute node. And I won't talk about the storage in the network node because it's very similar. It's capturing the similar ideas, and we have have a little bit of time to work with. So we're coming to the profile Nova Compute. And again, it's doing some consistency checking. It's pulling in the common code, and it's telling it that it is compute. One of the downsides to using this pattern is that if you want to put the Nova Compute and the Nova API on the same node, you need to make sure that the Nova Compute appears before the API in the parse order. Otherwise, this is going to come after the include, and Puppet's going to throw an error saying that the class has already been created. So it's just a little gotcha there. I'm not sure if it's the best pattern to be using. It was something, it solved a problem that I had, and clearly there are weaknesses to that. Sets up libvirt, which is another basic function that Nova is sitting on top of libvirt to manage virtual machines. And then you can do things like I have a custom QEMU configuration that makes sure that the libvirt is set up to allow network traffic to pass through properly. There's also an agent. Neutron is software-defined networking, and so you need to have an agent running on the system which is going to be handling your network traffic. So I'm going to pull in the common Neutron code and also set up an Open vSwitch. And this is just some network code, kind of more of the same, setting up a lot of different services, as well as setting up Open vSwitch. And so making sure that I have my ML2 plugin set up, and that I have my agent and my plugins set up for this. Right? One of the nice things about Neutron is you can use any different number of network models, and so you can use VXLAN, you can use hardware-provided networks, and so it's a really powerful and flexible system. The Puppet Labs OpenStack module just uses Open vSwitch right now because it's kind of a simple, if not very performant way to set this up. So that was a quick just rundown, just ran right through it to see kind of how all of this works. But really, one of the things I want to get away, that I want you to take away from this talk is to become involved in the community. If this is something you're interested in, to really engage and really become a part of this. And it's easy to do. You sign up to become an OpenStack contributor. It's like many other projects, you sign a contributor license agreement that basically lets OpenStack use any, it guarantees a license for OpenStack to be able to use your code. You can start reviewing code. It's a great way to get involved with the projects. You get your name out there, you start reading things that are going on, and people start seeing, it gets you familiar with the project, and it gets you involved with the community. You can start writing code too, so you can get really deep into the Garrett workflow. If you haven't used a system like Garrett before, it can feel like it's a little bit heavy to become a part of. But once you start using it, it's really amazing because it provides you this entire system where you can submit patches, your peers can review it, it keeps track of revisions to those patches, and so you can iteratively and with the community work on building your software out. And then when it's reviewed, it will, and during the entire review process, it also integrates very well with continuous integration. And then when it's merged, it pulls it in, and everything is ready to go. Garrett is great. And it also prevents any one person from controlling a project because you have a set of core contributors, and they can add and remove core contributors as the project grows and evolves. And so you don't kind of have the GitHub model where one person's controlling a project, and you send a patch up, and it may not, and if the project's abandoned, it may never be landed. And so it's just a fantastic community collaboration tool. Hang out with the developers on Freenode at the Puppet-OpenStack channel. It's active. We have developers all over the world, and so anytime you show up there, there's probably going to be someone there to chat with and maybe answer your questions. And there's also a mailing list, the Puppet-OpenStack mailing list on Google Groups. This is where a lot of discussion about future development plans happens. I'm also talking about nominating core reviewers, administrative things. There's a weekly meeting every Monday morning where the community talks about progress. This is another standard thing that happens within OpenStack communities. So there's really a lot there for a lot of tools out there for you to resources out there, and you can get involved at any level that you want. Okay. So that finishes up my talk. I'd like to say thank you for everyone for coming. But also thank you for all of the developers and the community members out there. And actually, I think that we have a lot of them in the audience. And so if you're a Puppet OpenStack or even a member of the OpenStack community, why don't you stand up and people can kind of get a sense of who you are, and and you can just kind of see how big the community is. Even it's pretty vibrant here in Puppet. So are there any questions?
We have just 4 minutes for questions, but maybe a couple minutes. Hello, hello. Yep, I do. Go.
Maybe I missed this, but you showed a bunch of different projects for the Puppet modules, and the code you were showing was from which one?
So the code that I was showing is actually from the Puppet Labs OpenStack composition module. So I wasn't very clear about this, so thanks for asking. What I was showing is how you can use the modules to build out an OpenStack system. So all of that was building on code from those different modules, but you can find that in the Puppet Labs GitHub.
Yeah.
Does Puppet module work with Ubuntu environment today?
Yes.
It does?
Yeah.
Okay. Thank you.
Are you leveraging exported resources, and if so, how?
No. The exception being if you set up Swift, which is the object store, it's heavily dependent upon exported resources because Swift storage nodes all need to know about one another so that it can replicate the data. And so as nodes come online, the exported resources are used to generate what we call ring files. And so Swift is actually one of the projects that requires multiple runs to achieve convergence.
He said, have you considered using etcd or console or something like that?
I haven't personally, but I don't know if anyone else from the community has.
Anyone else? All right. I think that's time. Thank you.